Hello, welcome friends. We shall continue our discussion. Last class we discussed about steel mill. Today we will take up textile mill. Textile mill is the one wherein cloth is produced. So what is textile mill? Textile mill is the one wherein the cloth is produced, and this cloth is produced in two stages. The first stage involves the transformation of raw cotton into finished yarn, referred to as a spinning mill. The second stage involves the weaving along with the dyeing and printing, finally giving us the cloth. So the two stages are spinning, weaving. Spinning, weaving. Now, keeping this in mind, we will try to understand the process of making the cloth and the drives employed at different stages for different activities. So the first one is the spinning mill. We look at that, the different operations involved here. The first one is picking, wherein the raw cotton from the field is converted into laps. What are these laps? Laps are the rolls of cotton, and this process is carried out in blow room. That room is called blow room. Have you come across this blowing operation, blowing of the cotton? Maybe some of you might have seen the bed makers, the bed makers, roadside bed makers, when they come to make the bed, first actually they take the raw cotton and then blow it so that the impurities are removed. Okay, so here the raw cotton is put on a conveyor. To blender it is taken, and then there it is broken. The blender breaks it, the raw cotton, and separates out heavier impurities like seeds, dirt, etc. You know, in the cotton there will be seeds. Along with that there will be some dirt also. That is to be taken out. That is done in the blow room with the help of a blender. The cotton then, which is devoid of the seeds and dirt, is further beaten and combed. Combing is similar to the way we comb our hairs. Here also it is that type of comb only. That operation is called as combing. It will be with teeth, and here it is done to pick out the dirt and put the fibers along lengthwise, along the length of the laps. We comb our hairs for that purpose only, to put them along the length of the combing direction. Similarly here also the beating is done and combing is done so that the remaining dirt is also removed and the fibers are laid along uniformly the length of the laps. So the whole process here in spinning is beating and then combing, beating and then combing. Are you getting this? Good. So that being the process, what are the drives used? Please observe carefully. The drives used are typically squirrel cage induction motors. Squirrel cage induction motor. and typically here the individual drive is preferred. Each operating point its own drive, and in this case the blow room, the spinning mill, the different parts of the machine run at required speeds, whatever that is expected, using gears and belts. That's how you communicate the drive torque to different points. And typically these motors are of half kilowatt to 7 to 8 kilowatt. It is squirrel cage induction motor with this power rating. That is the spinning. Okay. Next we will go to the next part. After that, in the spinning mill, the first part is picking. The second part is spinning cording. So we got in the first stage the laps, Next, those laps from the blow room are taken to the carding machine. This process is called as carding. Here the cotton fibers are formed. We form the cotton fibers by combing them over a revolving cylinder provided with teeth. All short lengths are removed. Lap is transformed into wide and thin web of cotton. This part is very interesting and important. The comb I mentioned, it is actually a cylinder with teeth. A cylinder with teeth. It is something similar to, in our case, we take a comb and then comb our hairs. We move our hand with a comb in our hand. Instead, you imagine there is a cylinder with the teeth on its surface, and that cylinder is rotated. That cylinder is rotating with its teeth. The teeth, the spokes are similar to the comb spokes. Now, we put our head near to that. Automatically, the hairs will be combed. The same thing happens here. So, the cotton fibers are formed by combing them over a revolving cylinder provided with teeth. All short lengths are removed. The lap is transformed into wide and thin web of cotton. This web is then gathered to form a rope known as sliver. You have a plane. This web is like a plane. You put it together and then make a sliver, a rope. That is called a sliver. This carding machine is driven by group or individual drive. It requires little high starting because that cylinder with the teeth is having a high inertia. So starting torque required is high. And for this process, the motor, the drive used is 3-phase squirrel cage induction motor with a rating of about 1 kilowatt to 4 kilowatts. Okay, so here it is the plane, the web of cotton, from that putting together a rope called sliver formed, and machine used, drive used is squirrel cage induction motor. Requirement high starting torque, the rating this much. Next, in that spinning process, drawing. From carding machine, we feed it to this drawing, wherein the slivers are passed through drawing operation. In the carding section, we got the slivers. Those slivers are passed through drawing operation, the same as earlier, again forming the rope-like structure involving preliminary and then finisher stages. And The drive used for this is three-phase squirrel cage induction motor with the capacity power rating of about 3 kilowatt to 6 kilowatt. Next, the operation is rowing. Rowing is the twisting process, twisting operation. Here, the earlier slivers obtained by carding and then by drawing, those are twisted, and the machine used for this purpose is called a simplex machine. And the motor is three-phase squirrel cage induction motor of the rating of about 7.5 kilowatt. And this motor needs to be having the capability of starting and stopping, and also the inching facility. That is required very much, inching facility, because if the loops are formed, then you will have to clear that. No? So the machine needs to be run very slowly. The twisting process I told, I don't know how many of you have the experience of forming a rope. Normally, when we want to make a strong rope, what we do? We take the threads and twist them, and take two such twisted threads and twist them. Like this, we go on having multiple twisting, ultimately leading to a very strong fiber. That is the importance of twisting. Twisting increases the strength. Next is spinning. Drawing out and twisting again. The output from this rowing until the final yarn is obtained. What we want to ultimately get is the yarn, the thread, which we use to make the cloth. So that yarn, that thread is to be very strong. To make it strong, we draw it, thin, twist it, put 2 or 3 or multiple slivers together, again twist. That process is continued. When the yarn finally is produced, this is wound on bobbins and stored. The yarn, the thread of the required strength is wound on bobbins and stored. The motor used for the spinning is three-phase squirrel cage motor with a capacity of about 7.5 to 11.3 kilowatt. And this spinning machine has to have the features like smooth acceleration. Why? To avoid tearing of yarn, the yarn that is involved there. Not only here, in all the earlier operations also, the material involved is cotton, very fragile, not very strong. Hence, the operation is to be very smooth. The acceleration, the sudden start to be watched. Otherwise, there will be tearing of the yarn. Okay, so we got now the yarn. The whole process till now, starting from raw cotton, is called the spinning mill. Okay, next with that yarn, now we can make the cloth. Yarn is what? Yarn is two-dimensional figure. I will make your imagination simple. Starting from cotton, we got yarn. Yarn is a line. It is like a line. Okay. Now, yarn is like a line, a straight line, let us say. And now, we go to the next stage, weaving. Weaving is what? Weaving is with that line. Now we want to get a plane. With that line, the thread, now we want to get a plane. Plane we will be having X and Y. That is where the weaving process can be easily understood. How I can get a plane with a line, putting multiple lines together, end of it. How do I get a plane with a line? putting lines together. So that process of interlacing two sets of yarns at right angles is called weaving. Now you try to imagine, or if you are already done earlier, recollect the art of making the mat. When you wanted to make the mat, mostly you took two leaves, long leaves, and then put them at perpendicular to each other and went on interlacing, putting below, above like that, and that way you started packing in more and more leaves and you got the mat. This you can try even with the paper strips also. So here we are interlacing two sets of yarns at right angles, giving us the plane, that is the cloth. And I told two sets. The set of yarn or the thread which is lengthwise is called warp, and that thread which is crosswise is called weft. Warp is lengthwise, weft is crosswise. Like I have one set of threads like this, another set of threads like this. You can put it easily in simple as horizontal threads, vertical threads, warp and then weft. These individual threads are called picks in the textile domain. So weaving is this interlacing, a very interesting definition. Next, we use a loom for this interlacing purpose, for the weaving purpose, for interlacing warp and weft according to a pre-designed pattern. Depending on this design pattern we expect, the motions are to be accordingly realized. What thread, how to interlace, in what way to interlace, so that when the cloth is made, it will give you that visual effect as you expect it. So the loom motor, looms can be manual also, looms can be motorized also. Nowadays they are motorized mostly. The loom motors used in the looms, the drives, what are those? Squirrel cage induction motor, 3-phase, and they should be capable of having multiple start and stops, because this interlacing process that requires start and stop, shuttling motion. It requires shuttling motion. It's actually called a shuttle, the one that goes to and fro, that is called as shuttle. Okay, now this loom machine, 3-phase induction motor, squirrel cage, weaving, giving us weaving, then spinning, 3-phase squirrel cage induction motor, rowing, 3-phase squirrel cage induction motor, drawing, 3-phase squirrel cage induction motor, cording, 3-phase squirrel cage induction motor, and picking, 3-phase squirrel cage induction motor. Did you observe that? At different stages we made a mention of the drives employed. No, all through we have made a mention of one drive, that is 3-phase squirrel cage induction motor. Interesting. That is the drive employed here, mainly because the environment is the textile environment, wherein there will be lot of textile particles all around. These textile particles all around are dry and they can catch fire very easily. That is why we cannot offer to have anything which creates a spark in this environment. Hence, 3-phase squirrel cage induction motor is used, because in the case of squirrel cage induction motor there is no physical contact as such, like brush and then slip ring, and hence there is no possibility of spark That is why we use a three-phase squirrel cage induction motor in this textile environment. That is one observation. The second observation you can make here, maybe you already observed that. Look at the ranges: 7 kilowatt, 3 kilowatt, 5 kilowatt, 7 kilowatt, 11 kilowatt. Look at the power ratings. Kilowatts, that do not much, 10-15 kilowatts. So the power rating of the motors required is less, not that much as in the case of steel mill. In the case of steel mill, you have megawatts of requirement, whereas here it is kilowatts, that too modest values. So the induction motor three-phase squirrel case of lesser rating we require. And then observe one more thing: smooth acceleration, multiple start stop, inching facility, T starting to be high. What are all these things hinting at? You can form a picture that the motor, whatever we use, has to be a smooth motor. That means it should give us smooth start, smooth stop, because the material we are handling is fragile cotton. It should be handled with lot of care, otherwise it gets cut. Okay, the motor should give you that type of performance. In addition to that, it should have the capability of inching also. The acceleration, the deceleration should be smooth. Multiple start stop should be possible. Inching facility, it should be able to crawl, run at very small speeds, because when the operation is going on, if by chance there is a lot of loops formed, you will have to clear the loops. For that you need to run the motor very slowly, inching. So all this gives us the requirement of the process involved here, and what fits in for this requirement is three-phase squirrel cage induction motor with the solid state control, with V by F control, all the modern control features, so that the smooth running will be there. And along with that, one more very important requirement is the speed should remain constant. The quality of the cloth that we wear depends on the quality of the yarn. The quality of the yarn, one important feature is how much uniform thickness it has. The uniform thickness of the yarn is dependent on the speed, constancy of spinning, rowing, etc. Only when these happen at constant speeds, the yarn will be thick uniformly all through. Then the cloth will be of better quality. That is why the speed control accuracy is very important. That again points to the induction motor with solid state control. Okay, so that's all regarding the cloth making. The cloth making involves first making the yarn, then using this yarn, weaving, giving us the cloth. After that is formed, you put the dye there, and then you put the designs there. There the additional operations involved, different coloring, different designs, printing of the designs you can do on that. Okay, so we'll stop there. Next class we'll continue. Bye, take care.